This is the continuation of part C, or this is continuation of problem number 14, and it is part C, and it says, for the given functions below with the restricted domain, find the inverse of x, or f of x, in their domain and range. So we've given two equations and also given restrictions. So for this problem, we need to find the inverse. And so we've got y is equal to x squared minus 2x. And what I'm going to go ahead and do is complete the square, actually. And so that would give me x squared. 1/2 of negative 2 is negative 1 squared is plus 1. So this is x minus 1 squared is equal to y plus 1. So now I solve for both of these. I don't solve, I switch my x and my y. So I get x plus 1 is equal to y minus 1 quantity squared. So you take the square root of both sides. The square root of x plus 1 is equal to y minus 1. We're going to add 1 to both sides. But we have a problem because when we take the square root, remember we always usually take a plus or minus. But we are only looking for when our range is going to be greater than 1, because even though this is our domain in our original function, becomes our range in our inverse function. So for our inverse to be greater than 1 of this function, for our range, it would look like, so it's going to be this side. So this graph is actually the plus version because we want it to be reflected about that line, so it's going to have to be the positive. So this will give me 1 plus the square root of x minus 1, x plus 1 is equal to my inverse function. So this is my function, and again I know it's plus because of my graph. And my restriction and my domain for this, for my inverse, for this was going to be, so it goes through the point 0, 2, and at 1, we have 1 minus 2 is negative 1. So it looks like this is our original function, such that x is greater than 1. So if I just look at this, so my range for my original function is from negative 1 to positive infinity. And so that is going to be my domain for my inverse is from negative 1 to positive infinity. And my range is such that from 1 to positive infinity, such that x is greater than 1. Yeah. Alright, so that is for the first part, and then we're going to do it again for the second question. And so now I have that y is equal to square root of x squared plus 2x. So I need to first square both sides to get y squared is equal to x squared plus 2x, and then I'm going to do complete the square. But this one is a plus now. Yeah, instead of a minus like this one is. So it's going to be x plus 1 squared is equal to y squared plus 1. So now that we have that, now we're going to switch our variables. So this gives me x squared plus 1 is equal to y plus 1 quantity squared. So I'm going to take the square root of both sides, and I'm going to subtract 1. And this was such that x is greater than 0. So when we look at our function, it's like that. And then, again, we are going to want to flip this about our line y equals x. So this is going to be plus again, because we want the upside, not the downside of the square root. So this is my inverse function. This is equal to inverse. And again, remember, we already know since this is the domain of my regular, it becomes the range of my inverse. And then the domain of this function is such that x squared plus 1 has to be greater than or equal to 0, so we subtract 1 and take the square of both sides, but it's actually going to be all real numbers. But not really, because the graph of this function, the range of this graph, is only from 0 to positive infinity, so that becomes the domain of this graph. So remember, you have to end up, for the range in the domains of inverse functions, you're going to have to find the range in the domain of the original first, and then that'll give you your domain and range for your inverse. So that is part C on number 14.